Okay, so today we're going to be working on lesson 1.2, which is evaluating and simplifying algebraic expressions. In lesson 1.2, we talk a little bit about some vocabulary here, and so some vocab that you should get down. And remember, if I go too fast on the vocab, you can always look in the back of the textbook and get definitions for these. I think probably more importantly, we should be making sure that you're getting the examples that I write down as an example for each of these definitions. But anyway, a power is an expression formed by repeated multiplication of the same factors. For example, a to the fifth power is the same thing as a times itself 1, 2, 3, 4, 5 times. And so it's the repeated multiplication of the same factor where each of these is the exact same number. We're multiplying that over and over by itself, in this case 5 times. A variable is a letter used to represent one or more numbers. Again, for example, x is equal to 2. This should be nothing new or unfamiliar to you. A term, an expression that can be written as a sum. The parts added together are called the term. So for example, 2x squared plus 4x minus 5 has 3 terms. All right, and so each of these parts added together. Now it says added, so technically speaking we should change this to add the opposite, so this becomes negative 5. The terms are separated by plus signs, and that will make your life much easier as we start to combine like terms much later on. Is to always change negatives into plus, or subtracts rather, into plus and minus. Okay. The next piece of this then is this word coefficient. Don't be intimidated by this word. Again, all this means is it's a letter before a number, or a number before a letter. So for example, 5x squared, the coefficient would be the 5. It's the number that comes before the variable component. It says when a term is the product of a number and a power of a variable, the number is called the coefficient of the power, so the number that comes in front. And again, that means that we have 5 of those. This is 5x squared, so we have that quantity x squared, 5 times that. The identity is a statement that equates two equivalent expressions. So again, when two things are equal, we say that it's an identity. All right, so nothing really too bothersome there. So the first thing we have to talk about is this idea of order of operations. Order of operations, many of you guys know as please excuse my dear Aunt Sally. Now, this is a little bit of a misnomer. Please excuse my dear Aunt Sally stands for parentheses, exponents, multiplication, division, addition, and subtraction. Now, as I said before, this is a bit of a misnomer because it makes you think that multiplication should be performed before divisions. Again, if you remember the expression, please excuse my dear Aunt Sally, if you remember that expression, that helps you to remember the order in which we do these operations. However, multiplication and division really don't differ at all. They're obviously two different operations, but the order of them, we do these two as they appear from left to right. So if you have a division prior to a multiplication, then you would do the division first. If you have a multiplication before a division, then you would do the multiplication first. Same thing is true for addition and subtraction. Again, if you're operating under the impression that please excuse my dear Aunt Sally works all the time, then you would be tempted to do adds before subtracts, and that is not necessarily the case. Once again, additions and subtractions are on the same level, if you will, in terms of our hierarchy, so we work those as they appear from left to right. So taking a look at our example here then, we say first do the operations that occur within our parentheses. So we're going to do our 5 minus 3, and so this gets rewritten as 1 plus, first do the operations that appear within the parentheses. And so we're going to simplify 5 take away 3 as 2. So the second thing we're going to do is we're going to evaluate any exponents. So we're going to evaluate exponents, or also referred to as powers. But I'll put exponents in parentheses here so that you know that that's the same as exponents. So we evaluate 7 squared, and 7 squared becomes 49. So now we do multiplications and divisions as they appear from left to right. And as you're taking a look at this, there's only one multiplication, so we just go ahead and perform that multiplication. 49 times 2 is equal to 98. And then finally we do our additions and subtractions again from left to right. And after we've performed those addition subtractions from left to right, we only have one addition. 1 plus 98 is equal to 99. Now we have to be careful here because, again, if we were to perform this addition, and I'll do this in a different color, if we were to perform this addition before we perform the multiplication, we would get 50 times 2, which is equal to 100, which is not necessarily the right answer. So you've got to be real careful about which order that you perform your order of operations. Okay? All right. Our next then is to evaluate an expression, and we're going to be evaluating this expression, negative 6y squared minus 11y plus 34 when y is equal to negative 5. So to evaluate simply says to substitute. Every place that you see a y, you're going to replace that with a negative 5. So this becomes negative 6 times negative 5 squared minus 11 times negative 5 plus 34. Now, if you are the type that trusts your calculator, I'm going to tell you that that piece of equipment that you purchased is going to lie to you. And here's why. If you do negative 5 to the second power in your calculator, it's going to tell you that's negative 25. This is incorrect. What you're really squaring here is you're squaring all of negative 5. So you're squaring negative 5. This is the same thing as the repeated multiplication of negative 5 times negative 5. Well, as you know, the product of two negatives is a positive. So negative 25, or negative 5 squared rather, is actually positive 25. Minus 11 times negative 5 plus 34. Now we're going to go ahead. We've evaluated our powers. Again, if we go back to our, please excuse my dear Aunt Sally, there was nothing to do within the parentheses of each of these. So we went ahead to exponents, and we performed our exponent of negative 5 squared. Now we're going to do multiplications and divisions as they appear from left to right. So first we're going to do negative 6 times 25, which is negative 150. And now we're going to do this, subtract 11 times negative 5. Well, subtracting 11 really says to add negative 11 times negative 5. And negative 11 times negative 5 becomes positive 55. And then we're going to add 34 to that. Okay? So our final step then is to go ahead and perform this addition from left to right. And so this is, again, this can really be typed in one step in your calculator. Since additions appear from left to right, we just go ahead and do them from left to right. This is negative 150 plus 55, which is like negative 95. And then we add the 34, and so you get negative 61. Okay? So I'd like you to go ahead and pause your video right now, and I want you to try the next two examples in your notes packet. If you take a look at the notes packet, if you've printed these off the internet, you should have these two examples ready to go. And so I'll have you go ahead and pause your video, try these two examples, and after you've tried them both, go ahead and restart your video and give a listen to the solutions to these. Okay, so number one, you're asked to substitute a is equal to 7 in here. So we're going to replace this a with a 7, and this becomes 3 times 7 minus 16. And now that we've done our substitution, we're evaluating when a is equal to 7. So we're going to do our parentheses, which there's nothing to do in the parentheses. There are no exponents. So we go to multiplications. Again, 3 times 7 is 21. 21 minus 16 is 5. All right, for number two, again, you're asked to evaluate when y is equal to 3. And so we're going to substitute in. This is 2 times 3 squared times, not y. That is 3, take away 10. And so we're going to go ahead and do our exponents first. Again, that's not correct. We're going to go ahead and do our parentheses first. So that is 3 minus 10, so this becomes 2 times 3 squared times negative 7. Now we can go ahead and perform our exponents, and our exponents say this is 2 times 3 squared. Be careful, because 3 squared is often thought of as 6. It is not equal to 6. It is 3, the repeated multiplication of the number 3 twice. So So it's 3 times 3, which is actually 9. So be careful with that. I do see that mistake quite a little bit. So this is 9 and then times negative 7. We go ahead and we multiply in order from left to right. 2 times 9 is 18, and 18 times negative 7 comes out to be negative 126. Okay, so let's take a look then at terms and coefficients and this idea of simplifying expressions. First of all, an expression it can be written as the sum. Again, we want to use sums here, we don't want to use subtractions. The parts added together are called the terms. A term that has a variable part is called a variable term. A term that has no variable part is called a constant term. So things like 5x, 4y squared, 8z, those are all considered variable terms. And constant terms are things that don't have x's with them, like 5, negative 2, 0, 8. Those are constants because, again, the word constant means it doesn't change. Well, these numbers don't change, they're constants. They're not based on some value of x. Whereas 5x, 4y squared, and 8z, those will depend on the values of x, y, and z. So those are variables because they depend on those variables. Again, constant terms don't change. And when a term is a product of a number and a power of a variable, the number is called the coefficient, which we've been over. Again, the numeric part of this is 5, and so the coefficient is 5. The coefficient of this is 4, and the coefficient of this is, as you probably guessed, 8. All right, so let's take a look at a couple of examples involving simplifying expressions. And let's go ahead and combine like terms for a few of these. We'll do a couple together, and then we're going to go ahead and have you guys do the last two. First of all, we're going to combine all the like terms, and we said that subtractions are no good, so we want to make this plus a negative and plus a negative, so that way when we combine like terms, we find all the ends and we add them together. Again, because this is all addition, we do them in order from left to right, we have to put them in order and put those things together that match. So 11n, take away 2n, is 9n. And negative 6 plus 14, well, by the way, after I combine those, I'm going to cross them off, so I'm not tempted to use them again. Negative 6 plus 14 is equal to 8. All right? We'll go ahead and we'll do number 5, and then I'll let you guys try 4 and 6 here. Don't forget about our old pal, the distributive property. This is 6x. And again, we don't like subtracts when we're combining like terms, so make that plus a negative. So this would be plus a negative 24. Big key here, this becomes plus a negative 3, and so we're distributing negative 3. Negative 3 times x is plus negative 3x, and negative 3 times positive 11 is negative 33. If you don't change that to plus a negative, you'd be tempted to forget to distribute the negative to both, and you'd end up with negative 3x and positive 33, which you have to be careful of. Now combining like terms, we're going to add 6x and negative 3x, which becomes 3x. Whoops. There we go. And negative 24 plus negative 33 comes out to negative 57. And if you want to go back and write that as minus 57 at this point, you can. All right, so go ahead and pause your video. I want you to try 4 and 6 by yourself, and then we'll come on back on and we'll double check the solutions for those. Okay, so if you pause your video and try these two, you'll see that this is plus a negative. And so now we want to combine only those things that have matching variable components. Again, those things that are called like terms. A squareds and a to the thirds are totally different quantities, okay? Because a to the third depends on the value of a, and we're going to multiply it by itself 3 times, and a squared is only 2 times. So this becomes 2a to the third plus 5a to the third, which becomes 7a to the third. And then you have this negative 6a squared on the end. That doesn't have anybody to play with, so he just stays as negative 6a to the second. There is no combination that can happen at this point. This is not 1a or anything like that. We're just going to leave them as 2 separate terms because they have different powers of a. All right? Negative 15y, and again, make this subtract into plus a negative when we're combining like terms. Positive 2y and negative 15y becomes negative 13y. Cross them off because I put them together. And now in terms of x, we have 12x and negative 7x. That becomes plus 5x. All right? Okay, so that concludes our video instruction for lesson 1.2. Hope this went well for you, and tomorrow we'll go ahead and we'll do some examples in class together.